This video is about Descartes' rule of signs. Descartes was a mathematician, and his rule states the following. Let P be a polynomial with real coefficients. Then there are two conditions for it. First, the number of positive real zeros of P of x, this polynomial, is either equal to the number of variations in sign in the polynomial or less than that by an even whole number. Now let's recall that an even whole number would be anything in the list 2, 4, 6, and so on. All right, and then secondly, the number of negative real zeros of this polynomial is either equal to the number of variations in the sign of P of negative x or less than that by an even whole number, same kind of thing as the first one. The main idea is that we're either dealing with P of x or P of negative x and then just counting the variations in the signs of that definition. Let's try an example where we use Descartes' rule of signs to determine how many positive and how many negative real zeros the polynomial can have. Well, let's take a look at P of x, and then we'll have to compute P of negative x. But looking at P of x and just considering how many sign changes there are going down the list in descending order here, we have positive to positive is no change. But then from the second to third term, notice it goes positive to negative. That's a change. And then from the third to the fourth term, it goes negative to positive. So that would be two sign changes overall for P of x. If we follow Descartes' rule, that means there could be two, or that number minus a positive even integer. Subtracting 2 from 2 would give us 0, but we can't go any lower than that to get a whole number amount here. Remember, whole numbers are like the positive integers. Now let's try to compute P of negative x to consider the negative zeros here. This will be just plugging negative x in for x. You'll recall when we did even and odd functions that if there's an odd power of x, of course it will turn the sign of that term, otherwise it will keep it. So this will turn it into negative x to the fifth minus 4x cubed minus x squared. It does not change the sign of that term that has the positive 2 power of x, and then minus 6x. So that's P of negative x computed. Now we want to look for any variations or changes in signs from term to term, but you'll notice they're all negative, which means the number of changes would actually be 0, and so you can't subtract anything more from 0, which means 0 it is. So to put this in the language of the theorem, the number of positive real zeros possibly for this polynomial would be 2 or 0, and the number of negative real zeros would be 0, meaning none. And this again is according to Descartes' rule of signs.